For more than half a century, traditional technology has been the engine driving human progress. From the invention of the microprocessor to the rise of the internet and smartphones, our world has been shaped by predictable, rule-based systems designed and controlled by humans. But now, something fundamentally different is happening. Machines are no longer just following instructions. They are learning, adapting, and in some cases, making decisions that even their creators struggle to fully explain. Artificial intelligence is no longer a futuristic concept. It's already embedded in our phones, hospitals, financial markets, and workplaces. And this raises a critical question: are we witnessing the next evolution of technology, or the beginning of a battle where traditional tech risks becoming obsolete? Today, we're diving deep into AI versus traditional technology, and what this struggle means for the future of our jobs, economies, and daily lives. The rise of traditional technology. To understand why this moment matters, we need to step back and look at how traditional technology shaped the modern world. Traditional tech refers to systems built on explicit rules and predefined logic. Early computers, for example, were designed to perform calculations at incredible speeds, but only within the boundaries humans set. Every outcome was predictable, every process transparent. This reliability fueled trust and allowed technology to scale across industries. The development of semiconductors in the mid-20th century laid the foundation for modern computing. Companies like IBM and Intel pushed hardware innovation forward, while software followed a structured path. Programming languages evolved, but they still relied on human, written instructions. Whether it was banking software processing transactions or manufacturing robots assembling cars, traditional technology excelled at efficiency, repetition, and control. The internet accelerated this progress. By the late 1990s and early 2000s, digital platforms reshaped communication, commerce, and entertainment. Email replaced letters, e-commerce transformed retail, and search engines made information accessible at an unprecedented scale. Yet even at this stage, technology remained largely passive. It responded to users but didn't truly understand them. The system was powerful, but it wasn't intelligent. What makes AI different? Artificial intelligence represents a break from that historical pattern. Instead of being explicitly programmed for every scenario, AI systems learn from data. Machine learning, a core subset of AI, allows algorithms to identify patterns and improve performance over time. This shift is not just technical, it's philosophical. We're moving from instructing machines to training them. The concept of AI isn't new. Researchers discussed it as early as the 1950s, but progress was limited by computing power and data availability. That changed dramatically in the last 2 decades. The explosion of digital data, advances in graphics processing units, and breakthroughs in neural networks made modern AI viable. Today, AI models can recognize speech, translate languages, detect diseases in medical images, and generate human-like text. Unlike traditional software, AI doesn't always produce the same output for the same input. It operates on probabilities rather than fixed rules. This flexibility makes it incredibly powerful, but also harder to predict and regulate. When an AI system makes a mistake, the cause isn't always obvious. That lack of transparency is one of the core tensions in the AI versus traditional tech debate. The productivity advantage, one of the strongest arguments in favor of AI, is productivity. Traditional technology increased efficiency by automating manual tasks. AI goes further by automating cognitive work. In industries like finance, AI systems can analyze market trends in real time, flag suspicious transactions, and assist in risk assessment faster than any human team. In manufacturing, traditional automation focused on repetitive tasks. AI-powered systems now optimize entire production lines, predicting equipment failures before they happen and adjusting workflows dynamically. This reduces downtime and saves costs. According to data from global consulting firms, companies that successfully integrate AI into operations often report significant productivity gains, particularly in data-intensive sectors. Healthcare offers another example. Traditional medical software stores and retrieves patient records. AI systems can analyze those records, combine them with imaging data, and support diagnostic decisions. Studies have shown that AI can match or exceed human performance in specific tasks like detecting certain cancers from medical scans. Importantly, These systems are designed to assist doctors, not replace them, highlighting how AI often complements rather than competes with traditional tech. Where traditional tech still wins, despite AI's rapid growth, traditional technology remains essential and in many cases, superior. Reliability is a major factor. Rule-based systems are predictable and easier to validate. In safety, critical environments such as aviation, nuclear energy, and core infrastructure, predictability matters more than adaptability. Traditional systems are easier to certify, audit, and control. Cost is another consideration. AI development requires vast amounts of data, specialized hardware, and skilled talent. Not every organization can afford that investment. Traditional software solutions are often cheaper, easier to maintain, and sufficient for many use cases. A small business managing inventory doesn't necessarily need an AI-driven platform when a conventional database works perfectly well. There's also the issue of data quality. AI systems are only as good as the data they're trained on. Biased or incomplete data can lead to flawed outcomes. Traditional systems, while less flexible, don't inherit bias in the same way. This makes them more suitable in scenarios where fairness and consistency are critical. The workforce impact. Perhaps the most emotionally charged aspect of this battle is its impact on jobs. Traditional technology already transformed the workforce by automating physical labor. AI threatens to automate cognitive tasks once thought uniquely human. Roles in customer service, data analysis, and even content creation are being reshaped. However, historical data suggests that technological revolutions don't simply eliminate jobs, they change them. While AI may reduce demand for certain roles, it also creates new ones. Fields like AI engineering, data science, and cybersecurity have grown rapidly. Even non-technical roles increasingly require AI literacy. The key difference this time is speed. AI adoption is happening faster than previous technological shifts. This creates a skills gap that education systems and companies struggle to address. Traditional tech evolved gradually, giving workers time to adapt. AI's pace demands proactive investment in reskilling and lifelong learning to ensure that the workforce isn't left behind. Ethics, control, and trust. Traditional technology gave humans direct control over systems. AI complicates that relationship. When decisions are made by algorithms trained on massive datasets, accountability becomes murky. Who is responsible when an AI system makes a harmful decision? The developer, the user, or the organization deploying it? This concern has prompted governments and institutions to develop AI regulations and ethical guidelines. Transparency, fairness, and data privacy are central themes. Traditional tech fits neatly into existing regulatory frameworks. AI often doesn't. This regulatory lag fuels skepticism and slows adoption in sensitive sectors like law enforcement and public administration. Trust is another challenge. Users are more likely to trust systems they understand. Traditional technology is easier to explain. AI, particularly deep learning models, operates as a black box. Bridging this trust gap is essential if AI is to coexist with traditional systems rather than replace them entirely. The economic power shift. The AI versus traditional tech battle is also reshaping global economics. Countries and companies investing heavily in AI research are gaining strategic advantages. Major technology firms now allocate significant resources to AI development, viewing it as central to long-term competitiveness. Traditional tech companies face a choice: adapt or risk decline. Some have successfully integrated AI into existing products, while others struggle with cultural and structural barriers. Startups built around AI-first models often move faster, challenging established players. This dynamic mirrors previous technological shifts, but the stakes are higher because AI touches nearly every sector. At the same time, traditional infrastructure remains critical. AI doesn't operate in a vacuum. It depends on data centers, networks, and hardware, all products of traditional tech innovation. Rather than a clean break, the future appears to be one of deep interdependence. Collaboration, not replacement. Despite the framing of a battle, the reality is more nuanced. AI and traditional technology are not mutually exclusive. In practice, the most successful systems combine both. Traditional software provides stability and structure. AI adds adaptability and insight. Consider modern search engines. At their core, they rely on traditional algorithms for indexing and retrieval. AI enhances them by understanding user intent and personalizing results. Autonomous vehicles blend traditional control systems with AI-driven perception and decision-making. Neither approach alone is sufficient. This hybrid model suggests that the future isn't about choosing sides, but about integration. Organizations that understand where AI adds value and where traditional tech remains essential are better positioned to thrive. Looking ahead, as we look to the future, the question isn't whether AI will replace traditional technology, but how the two will evolve together. Traditional systems will continue to provide the backbone of digital infrastructure. AI will increasingly act as an intelligent layer on top, enhancing efficiency, personalization, and decision-making. The challenge lies in managing this transition responsibly. Investment in education, ethical frameworks, and transparent governance will determine whether AI becomes a tool for broad societal benefit or a source of inequality and mistrust. History shows that technology reflects human choices. AI is no different. We are living through one of the most significant technological shifts in human history, and its outcome is still being written. The battle between AI and traditional tech isn't about winners and losers, it's about how we shape the future together. If you want to stay informed, think critically about where technology is heading and be part of the conversation that defines the next generation of innovation. Make sure to subscribe to this channel. If this video helped you see the bigger picture, hit the like button and share it with someone who's curious about the future. And stay connected, because the story of technology is far from over, and we're just getting started.